Hi, good evening. Simon's going to introduce this because he organised it.
Welcome everybody. So between Vic and I, we're running these makers nights once a month. I did one last month. This month we've invited Robin to come and teach us all how to solder properly. Couple of reasons. One, Robin knows what he's doing, and we should actually get somebody on here who knows what they're doing. But secondly, I think a lot of people are nervous or feel they haven't got the skill to do some of the basics around soldering. So this is really aimed at demystifying soldering. It's not an expert masterclass in the detail of surface mount, but we're trying to give you an appreciation of what you can do, an appreciation of how easy it is to do, and enable you to go off and make some patch leads and fix some components and just generally, wave a soldier iron about without setting fire to your house. Without further ado, Robin, over to you.
Okay, right. First off, if I go do that and that and that, there's a document there that I've put on the community development. You're welcome to look at it. Soldering is easy. So that's your reference manual for tonight. It's got lots of pretty pictures in of how to solder and some bits of advice and things. And it's only 8 pages long. And you know what? If you have your own crayons, you can print it out and color it in. So that's the first bit. So that's it. That's all done now, isn't it? No. Soldering. Like Simon says, there's people that have never done it before can be a bit frightened of it, and it's a bit overwhelming. However, as radio amateurs, one of the first things you want to do probably is to make a lead or put a plug on the end of some coax so you can put that expensive radio onto a piece of ironwork and start transmitting or receiving even. So the first thing I'm going to do, I'm going to have a look at some tools, and any questions, just fire away because there's only 6 of us. Just shout out your questions and I'll try and answer them. And then after I've looked through the tools, I will fit an SO 239 at the end of a bit of coax and explain how easy that is to cut your fingers and burn them. Hopefully not. And then later on, we will have a look at pulling some components off an old board and then fitting a component onto a new board. And that's about it. So any questions, just shout up. So if I hit the share screen again and no, I don't, because that didn't work. If I change my camera, because that works, you should get an overhead view. All that stuff there. Okay, right, let's start with the simple bit. That one there is a 250 volt, 25 watt or 15 watt soldering iron. I'm not sure what it is. Made by Antex. They're dirt cheap. They work for what they are. So plug it in, it stays on. That's the hot bit. And you hold it here. You don't hold it here because you burn your fingers. Okay. You need to look after your tip. That's that bit there. And make sure that it's got some fresh solder on at all times. I'll demonstrate that on the other iron in a minute. That one's being used today, but it's not the best tip in the world, so it's not nice and shiny, but it works. If you're using a soldering iron, you need to have something to put it in. This is one what I pinched off work. Grand thing, big clamp on it, but you can stand like that and stick your iron in it. That way, you're not going to burn the carpet, your desk, your friend, or yourself. Okay, so basic soldering safety. The next one, dead useful for in the garden, the gas one. Put the lighter gas in it, and gas comes out there, and you light it, switch it on. It's hissing. The gas comes on, and in a minute, the elements in there, there's some stuff in there where the flames are, will start glowing red. Hopefully. There you go. Turning red now. Heating the iron up. Get some fresh solder. And we should find that the end of it, the solder melts on there. Okay. Simple and useful. Trouble is with them, when the wind blows, they're useless. But small iron like
I have a question, Robin.
Yeah.
What's going on with your thumbnail?
Oh, that one. It's upside down, mate. There. A little fella. Isn't everybody wearing them? So I'll put that safe out the way where it won't fall over and melt me dead.
How long do they run for on a gas canister?
I'll not say hours, but you just top them up. How long does that last?
Oh, so it kind of burns the rate. Okay.
Yeah, it doesn't burn a phenomenal amount. You can get a lot bigger ones. You can get ones with interchangeable bits, which I used to have. That one was, I think that was an Aldi cheapie for about £4. So I thought, oh, I'll have that, come in handy, because my other ones were knackered. They've been in the garage. I used to have them with self-starters on and everything, little piezoelectric things, super things, but they were left in the garage too long and they got rusty and didn't work. And I pulled one out, used it one day, it was leaking, so I ended up with my arm on fire. So that got slung straight in the bin. Otherwise, that's the selection of 2 irons. This one here, this jobby here, I inherited from a factory. It fell into my toolbox on the way out. This is manufactured by Weller. It's temperature controlled, so you can turn the temperature up and down. Instead of 270, which is about the normal one, and turn it down to 260 if I want. Some solders melt at a lower temperature, and it's got interchangeable bits. There, it's hot. Selection of bits in the box here. So there's that one there, which turns into a very fine point, which is you could use for surface mount individual components.
Oh, they're just the tips, aren't they? Not the mine's a heating element and a tip in one.
And that's a chisel end, useful for desoldering, etc. Variety of bits that they're not cheap, but they do last a long time. And that one, it's an outer sleeve. The element's on the iron. It's an outer sleeve that holds a bit in place. I'll just tin that to make sure it's clean. That's the art of tinning. Got a bit of solder on it. The solder I'm using here, this one is lead free. Sorry, this one is leaded. So it's a mixture of tin and lead with a resin inside, which is the flux. This one here is my old stuff from work, which fell into me when I retired. I emptied my van into my garage, and there's all these coils of solder and things, all sorts of useful things. And this one's a slightly bigger one, and this one is lead free, so it has a slightly higher melting point. And most people will tell you that tin and lead solder is much better to use than the lead free. Lead free because lead's bad for you. I've spent 40 years soldering with leaded solder. It hasn't affected me that much. I forget things a lot now. But leaded solder with lead in is often said to work better, and I think it does as well. Other things you might need. The iron stand here has got a sponge in it. Just one of those cheapo sponges with some water on it. So to clean your bit, that cleans the end of your bit. Okay. Or even better, one of these. And that is some oxide-free metal shavings, for want of a better word. And that is excellent for keeping the iron clean because it's slightly abrasive. It takes the solder off, it takes the flux off. That's a spotless bit, ready for tinning again. Leave that there. What else is there? If there's not enough flux in here to get your solder to run, there's that. You dip your iron in it, or you can brush it onto your solder board. Or there's flux here, which is like Simon's nail polish. It's got a little brush on the end of it, and you apply the flux to the object you're soldering. It helps to make the solder flow and prevents it from oxidizing while it's heating it up. Lastly, that one is a pen with flux in it. So if you're removing components, or this is quite useful for removing components where you need extra flux on, you can pop it right on the pad when you're removing. That is quite expensive. That is dirt cheap. That's quite pricey. So that'll do for most things. Lastly, on the list here, a couple of things. Where did I put them? There. Something to desolder with. That one there, you charge it like that. You push the button, and it sucks the solder up the nozzle here. So the body contains burnt bits of solder. which you need to flick out. They're reasonably cheap. You can get electric ones, which cost hundreds of pounds. As somebody who is desoldering every day to as a repair job, would have an electric one. This does. Lastly, some desolder braid, which is like the stuff on your coax, but a bit finer, and you can use that to wick up solder off pads to clean them up in preparation for replacing a component, for instance. Everybody happy so far? Good. What else? What other tools might you need? If you're soldering, you're cutting wires, so you need a pair of fine cutters. Right, these are surface cutters. They're razor sharp. £3 from Chinesian.
Buy 10 at a time is my advice.
Set of them. Fine nose pliers are useful. The small components, some tweezers. That type there, or that type there, which actually hold it. So you can pick up a component and it holds.
There's also the specialist L ones as well for removing chips.
Yeah, and there's also ones around the corner, so you can pluck your eyelashes while you're on the take. What else might you need? You might need something like that to cut insulation, etc. Happy so far?
Yep.
Right. Nitty bitty, find some coax. So I found some coax and I found an end. And guess what? As we normally find, it doesn't quite fit. So you've got a box of ends, PL259, and some coax. Now, what's useful with these, you can unscrew. So that bit there, if you're going to put it on the end of your coax, you need to put it on the coax first. Just put a knot in the end of here so it doesn't drop off. So that goes on your coax first. All right. Don't forget it.
And get it the right way round.
Yeah, the right way around. You might need
Don't ask me how I know that.
You might want some heat shrink sleeving. Now, the best sleeving to use, especially externally, is the stuff that has an adhesive on down the center. So when you heat it up and it shrinks, it glues as well. So what we need to do with that is probably.
Say that again, Robin. I've not seen that. I've only ever seen heat shrink that just shrinks. So that's got.
This hasn't got adhesive. You can get heat shrink with adhesive in.
Can you?
Which is really
glue
useful
heat
for
shrink.
outside.
So it heat shrinks it and glues it all at the same time.
I've never seen that. I've only ever had straight heat. Oh, I'll have to look for that.
Right. So I was saying that the coax isn't the right size. These ends come specifically for the size of coax, but there's 1,000 manufacturers of these of various quality, and there's more manufacturers of coax of even greater quality. This is cheap, nasty coax with a fairly decent end. Now you'll find that it's just a loose fit. Your coax needs to be a fairly firm fit so that when you do screw it on, it actually makes good contact with the braid. However, there is a way around that. So select your coax to put an end on. Put it up against your plug like that. So there's the end of the plug, the end of the coax, and there's the end of the connector. But you want to strip to that point there where the screw thread starts. So you get your knife, and this takes practice, so it's worth practicing. You gently twist the coax, and you make a cut just through the outer covering. And if you've done it right, it should just split. Let's start to split. Before you do that, once you've got your cut in, get a little bit of insulating tape, because what we're going to do is make the coax a little fatter. And I'll probably a turn and a little bit will be enough for this. Put it with the wrong hand. Right-handed scissors, cut by left-hander. How's that? How's that for skill? So now we can take that off. Hey presto. So that's that strip there. The next thing we need to do is turn back the braid. You can see this is cheap coax because the braid's full of holes. A good braid is fairly solid. So you turn back the braid so it's over the outside of the coax and the tape will put on. That's fairly simple, isn't it? Next bit, there's a bit of foil in there. We need to get rid of it.
Fancy coax.
Yeah. The foil is plasticized, so all you need to do is open it up like so. I don't know if you can see that. And then just give it a nip with your cutters, and then you can tear it off.
Like tinfoil.
There you go. So that's that bit done. The next bit, we need to strip off the dielectric and leave some inner bare. Again, offer it up to your plug. That's where it's going to sit. And in there, you can see where the surface is at the other end of this pin. So line it up like so. It's about there. Put your thumb on it, thumb with a little man on. Again, what you're doing here is cutting very gently. Basically, you're scoring it so it'll snap. Score a bit more. This is where the practice bit comes in, because this is polythene, it's difficult to cut. I need to give it a little persuasion. No, keep going. There you go. So that's successfully stripped without trimming any of the copper wires. Ease it off slightly. You go like that and twist it. Happy so far? Okay. Yeah. Next thing, get your helping hands, which is just a device with some clamps on it. And clamp your coax. That in view? Yeah. Shoulder. Soldering out. Now what we're going to do is tin the inner conductor. And by tinning the inner conductor, what we're going to do is warm it up with the iron with some solder on to tin it, and apply some solder on the opposite side so that the solder melts into the inner conductor. Once it's warmed up, we'll just slide it down towards the end, and then all that copper is now silver. All right, can you see that okay?
Yeah.
Finish with that for just now. Next job, making sure that we've got our retainer and our heat shrink on, and it's on the right way, good to go. Pick it up, and all you're going to do is thread the inner into the center of that pin, which you can see through the windows, or you can feel it. Once it's at that point there, you just screw it on. And what you do is you look through the windows until you can see the braid turning back. See the braid turning back in there? I think you can. That's it. Helping hands again. And clamp your cable in so that's slightly uppermost. Now this time you want a fairly clean iron.
Move it up a bit, Robin. You're just out of shot at the bottom.
Yeah.
There we go.
So, iron and solder. So the iron's tiny bit of solder on the end of the iron, because what you don't want to do is get solder and flux on the outside of the pin. Hands are shaking. Let it warm up, and there's the solder melting. Keep it there, keep applying the solder, because you're going to fill up that center. There you go. So there's a good solid bit of solder in there, not quite filled it up. The heat draws the solder towards the iron. So now it's the solder is completely surrounding the inner, and it's in contact with the inner side of the pin all the way around. Next job, trim the end. This will go pink, so put your finger over it so it doesn't fly. So that's that bit there. You can leave those bits on, doesn't matter, because what we're going to do now slide our heat shrink up. And you're going to heat it up. Now, you can use your iron to heat it up. You can use a hot air gun to heat it up. You can use a paint stripper. Paint strippers are good. Electric paint stripper. Got one in the garage, a big thing, big noisy thing. Or you can use a lighter. And all you're going to do is apply heat to the heat shrink, and it's going to shrink down. It's got a good grip. Go. Last bit. And it's still warm. Okay. One end soldered on. Everybody happy with that so far? Any questions?
No, what I would say is sometimes if you get a rough cutting edge on the top of the bit you cut off that goes through the plug, you could always use a really small file to smooth it off, so it just has a better connection inside the other connector.
You've got nice sharp cutters, that's fine. So the final check, because what we need to do now is make sure that our coax is good. Put the buzzer on. Put the buzzer on. Put the buzzer on. So what we're looking for between the braid and the center conductor
Up a bit, Robin.
is open circuit, yeah. Then we can test from the braid, from the center to the center, and the braid to the braid for continuity. I'm not going to do it because we normally have another plug on the end of it. What about a long run? Well, put your dummy load at one end and measure 50 volts at the other. Or if your antenna's got a transformer in it, you're going to get a virtual short circuit. So leave it unplugged. If it's open circuit from the shack out over, put it connected to your antenna, and if it's got a transformer in it, you'll see a virtual short circuit.
Oh, is it? Before she went down. No.
Yeah. Everybody happy with that?
Yep.
There's lots of other ends to put on. Compression ends, different techniques, but they generally come in a packet with the instructions because there's lots of parts to them. BNCs and SMAs are a little more difficult because they're smaller, but they can all be soldered. We're working well. Next bit, I've got an old circuit board here. It's an old ATX power supply that I've taken some bits off because I wanted to play with the inductors on it. Removing a component. So to remove a component, say for instance you're fault finding on a board and you think you've got a faulty component, and the only way to test it is to remove it. You need to identify which one it is. And of course, when you turn it over, it's all in mirror and no labels to say what it is. So it's a bit of trial and error. So what you can do is, say for instance, we're going to take this big nasty resistor out here, nice and easy one, okay? We need to find that resistor on the other side of the board. Well, the way to do it is to measure and look and see what's connected with it. And that resistor is.
He looks like such a typical college student.
That one and that one. Okay, so I need to desolder them. So normally what you'll find is if you straight away try and desolder from a board, you can't get the solder to melt, and you might need some flux on it. So you can get some flux. Find the end again. That one and that one. It just helps your solder melt.
Or relax.
Extra flux.
Put the glasses on. I need glasses for this. Whoa. That one and that one. So these are the ones we're going to take out. So what we're going to do is add some more solder to the joint.
Did you check the weather in London?
It's gonna be like Really good Friday, Saturday and Sunday, it's gonna go down a little bit, but not a lot, it's like 15, 17. And then it's gonna go up to the 20s.
The 15, 17
The next
is
job,
what,
Chilly.
next job is
60,
to desolder it.
50, 60.
So soldering sucker, charge it up, make sure it's clear. Iron on, warm it up until it melts. You feel it when it melts, you can see it when it melts. Put the sucker on, and everything goes pinging away. So you'll see there, I don't know if you can see it, but the solder's disappeared. Charge it up again, get some ends out. Try the second one. If that's been successful, that transistor should come out. I mean, that resistor should come out. It's as easy as that. Didn't that one work well? Sometimes it doesn't come straight out because the ends are bent over. Other times it can come straight out. You might need to persevere. So those two pads there, can't really see, that actually come out dead clean. So I don't need to do any further cleaning. So I was going to replace that component in there. I can pop it straight back in and solder it up. Pop it in. This is where you need 3 hands. Oh. So what I've done is melted it slightly, so it just holds on. Solder in. So what you're trying to do when you solder is ensure that it's shiny and it's rounded and it's got a meniscus. The booklet that's on the that I've uploaded explains all that, and that is it. If it was a brand new component, say for instance you're putting an LED in, I'll find a slot to put an LED in, 2 holes together. Where are we? There, there's 2 holes together there. Put the wires in. This one's going to go down the board. The wires are sticking out there. You just spread them slightly, which holds it in place. When you put it down like that, it's fine and happy. Soldering iron, again, tin the lead, tin the end. There's an end there. Iron in contact with the pad and the lead. Let it warm up and then apply the solder. What you're making sure is that you fill the entire hole with solder, which means it's got a good hold on it. Don't know if you can see that. Need better cameras. Once you've done that, you just trim the ends. Again, finger over before you cut it. Check that short enough. They're short enough. So there's a power supply board with an LED in it. Everybody happy? Any questions?
So, Robin, what do you do when you get one of those really stubborn ones where the problem I always have is things like MOSFETs where it's just sinking all the heat? How do you desolder those?
Well, this afternoon, where did I put it? I pulled out a heat sink with 4 transistors on, which was across here. And that took some time, but it just had to keep working on it now. What you don't want to do is overheat your components.
Yeah, that's my worry, is that I don't want to leave the iron on there because
Yeah.
you're going to cook everything off.
I'd need to put this in a vise to hold it. These are useful. It's just a cheap old Jill stand from the middle of Lidl. Would you believe?
Oh, I love it.
This is where you need a vacuum pump desoldering to really. Nearly there. Nearly there. So that's held. So you can see here that this heatsink runs down here. There's a MOSFET there, a MOSFET there, there, and down here. And also the heatsink is secured by big tabs. There's a big tab with a heatsink on it. So making sure you've got a big enough bit. Use some fatter solder this time. So your first one, fire it was. This is on the heatsink, so they can put plenty of heat on it. Nearly all gone. So that's now clear. That tab on the heatsink is now clear of solder. So basically what you do is you do all the components and all the tabs, slowly taking solder off. But you go from, do some here, come up the end, and go backwards and forwards, allowing the components to cool down. Because eventually what you're going to do is pull out, in this case, 1, 2, 3, 5 MOSFETs, and then test them, because it's probably easier to pull out the whole heatsink to test them than it is to take each one out individually. So having taken the one out there, you can do that here. But yeah, it's just a matter of time. The difficult ones to pull out are chips, because heat on them is going to kill them anyway. So if you need to pull a chip, I would suggest you put a new one in anyway, because you can't really test them unless you've got another circuit to put them in. So if you're going to pull a chip, put a new one in. But capacitors, resistors, you're fine. Most transistors, you're fine. But that's the biggest problem: big heat sinks and big MOSFETs. And the thing is, go to your rubbish dump, and if you've got any old computers there, just say, "I'm looking for some computers for bits." And if they say, "Oh, just take one away," take one away, and you'll find a power supply in it, and practice taking it to bits. Or you can buy perf board like that, little sections for prototyping, and you can practice soldering components in, or you can build little circuits on here. I've got an amplifier somewhere that I built, but I can't find it. I built it and used it and put it away somewhere.
Cool.
There he is back again. Take these off. Let's see it. Any further questions? No?
What are the widths of, so if anybody was to go and buy a soldering iron and the solder, like there would be lots of different widths. There would be 0.8 and 0.6 and 0.5 and 1 and 2, and you know, what's the overall run?
This
runner?
one's 0.7.
Hmm.
That one here, the smaller is 0.7. This one is old BT stuff known as solder number 2. The label is so worn out. 18 SWG, whatever 18 SWG is, probably
18 gauge.
probably 0.5 or 0.6.
0.75, I think. Because 17 is 1 mil.
Have you found it? I've got a micrometer somewhere. Lost it. I've got a vernier gauge somewhere, but I can't find it. Yeah.
1.2 millimeter.
So I would suggest you want some fine stuff for fine work and some fatter stuff for fatter work. In back in the day when I used to have to solder on sort of SMA size connectors, the solder we used was, I believe, it was 0.4 millimeter, and used to put that in the hole on the end of it, about 0.5 millimeter of it. Chop it off with your thumb, and then you'd warm it up and squash it together, and that would do your soldering joint. And that was onto a solid core coax, but that was years ago. And then they invented crimps, so it was a lot easier. Talking about crimping, crimping is by far superior, but you need the correct crimp for the job. and there's 1,001 connectors, all different and all need their own crimper. So it becomes horrendously expensive. So the radio amateur will solder and crimp most things, unless he knows the crimp is specific for what he's using it for.
I can attest to that. I used to crimp lots and lots of different connectors, and it was a nightmare.
Yeah, I've still got probably 5 or 6 pairs of crimpers in the garage, which were in my old toolbox from work. They'll never be used again. There's a couple that I've used for RJ45s and RJ41s, which I've done a couple of times. And generally, that's it. If you're going to do the accessory socket on the back of your radio into one of these DIN plugs, the way to do it, it's long-winded, but I recommend the best way to do it. That is the plug base there. First thing you're going to do is put that in a vise, hold it steady, and you're going to apply solder to the hole of every one of the pins. So each hole's got some solder in it. Then you're going to get your cable with all the wires in, and you're going to prepare the ends and strip them less than the depth of those holes and tin them. Then you're going to put some Sister-Select sleeving over that wire so it just fits. And this is just for preventing short circuits. So then you get your bit of wire on a fine pair of pliers or tweezers, warm up the pin with the iron and hold the wire in when the solder melts, take the iron away and allow the solder to solidify. Once you've done all your pins, 1, 2, 3, 4, 5, 6, this is 8. Once you've done all 8 pins, you then take the sleeving that you put over the wire and slide it down so it covers the joint. And that means there's no chance of a short circuit between any of the connectors. Now, I did probably a couple of thousand 25-way D-type connectors in my lifetime, building old data networks. And they were all done by hand and took hours, but that was definitely the way to do it. And I don't think we ever had a fault. So, thing to do, if you're going to put plugs on, don't say, I'm going to do this plug now. Buy half a dozen of them. They're cheap enough, and practice to get it right, because it's not something you're going to be able to do straight away. It's certainly something, if you want to do it, you need to practice it. Or you buy a long cord with 2 on each end, you chop it in half, and then there you go, Bob your uncle, you've got one end done already. Or you buy an ICOM and it comes with one of these with some tails on. Any questions?
So what about soldering pastes and these guys?
Soldering pastes are used for surface mount technology. I've never done surface mount. One day I might have to. But pastes are applied through a mask, or you can paste them directly onto your pads, and when you warm them up with hot air or applied heat to the component, the solder, the paste melts and it runs towards the metalwork. It's something I've never used. I've seen it done. I'm damn sure I could probably do it if I had to. I haven't needed to do it. My smallest stuff, it's stuff like this, or a bit finer, because it's a power supply and discrete components and chips. I haven't done surface mount, but one day I might have to.
You can solder surface mount just soldering,
Yeah,
but
you
it
can,
will
yeah.
take you absolute hours.
Yeah, the
And-
tip there is to, if that was a surface mount component and you put it on your board, you'd hold it with your tweezers and solder one end of it, so it's just about right, and leave it, tiny little bit of solder, let it cool down, then you do the other end with a good application of solder, then you'd come back to the first end and redo it. That's the technique I've seen. I believe it works. I might try it one day. In fact, I've got some surface mount stuff coming from China, and I've got some boards coming from the States to build some filters. So there you go. I'll let you know how I get on. But I've got 3 boards and 100 each of the components, because that's the minimum order for the strips. So I've got plenty of components, and I've got 3 boards coming, which should be enough to cock it up a few times and get it right. Hopefully.
So, Robin, what about the temperatures of the irons? Like, where do you start? You start with 250.
I always start at 350, and generally I leave it at 350. It might be too hot for some things, but I've never had a problem with it. Sometimes you'll find that some boards, especially if they're old boards and you're repairing them, the printed circuit on them could be quite fragile, and too much heat might lift it off the board, or conversely, too little heat means you can't solder the component properly, and you start shaking the pins of the component, and the trace comes away, and then it's a matter of trace repair, which is an art in itself, but it can be done with patience.
I was going to say I've ripped pads before now because I just haven't got it hot enough and it just comes away.
Yeah.
Oh, it's a nightmare.
Yeah, the idea is to get it hot enough so that any heat that's drawn out of the iron isn't more than what can melt the solder.
Yeah.
That big heat sink, that will take a lot of heat. But as you saw, it didn't take me long to get one of the tabs freed off, and that is completely free because I can move it in the hole with my thumb, so it's not sticking anywhere. But it would probably take me at least half an hour, probably more, to get that heat sink and all those MOSFETs out. But I can get them out because I did one this afternoon. Can't remember what I did with it.
I mean, if you were welding, you'd use a temperature crayon, wouldn't you? So you knew what your temperature you're at. But there's no sort of equivalent for soldering, is there?
No,
You just got to do it.
Suck it and see. If the
Yeah.
solder flows, it's good.
It's
That's
like do it by eye, basically.
That's the one I took out this afternoon as a practice.
Yeah.
And that took us about 10 minutes, I think, 10, 15 minutes. And that's good. 2 pins there and 1 pin there, and the rest is the 3 MOSFETs on it. But yeah, it can be done. But the thing is that if it's something you've never done, have a look at the hundreds of videos of people repairing stuff. It's a bit like slow TV, watching somebody chunter on repairing stuff or making stuff. And there's a few of the guys about that do it. There's a few that I watch regularly just because they're so entertaining. They're better than Love Island.
I happily watch Big Clive solder.
Yeah, I watch. I can't remember what they're called now. Hang on. Find my browser. Where's my subscriptions? I'd share a screen, couldn't I? IMSAI guy. He's Canadian, I think, and he does all sorts of repairs, things he's never looked at. He's quite good. And Learn Electronics. It's a guy that lives in the Canary Islands. He does a ton of stuff, and he seems to be able to fix anything. He's magic, but he's interesting to watch. He's got lots of good tips as well. Doesn't specifically talk about soldering, but when you see him desolder and solder stuff, he has a little explain of what he's doing. And the other guy is Ian FX here. He does everything on his kitchen, and he got wrong and had to fit a new bench to repair it all because he burned it with his soldering iron. But never mind. So that's Ian XFS. He's a ham. Can't remember. It's M0 something. The IMSAI guy.
We're just seeing your files.
Yeah, it's your download folder. Luckily, it's not too dodgy.
What's that one there? Why am I sharing that one?
You tell us.
I don't know. Where are we? Let's try again. Screen share. That one. Is that better?
Yes,
Yeah,
there we go.
that's the
yeah.
one.
Yeah. So this is the Learn Electronics guy. Here's the guy in the Canary Islands. He's got to have he talks a bit funny occasionally. He's got the most amazing hairy hands, but he's quite interesting. And this is the Canadian guy, IMSAI, because he fixed an IMSAI computer, whatever one of them is.
Oh yeah.
But he does some interesting stuff, and he buys kits for cheap, but then he builds them and they don't work, and he fault finds on them, then he puts them in the bin. But those are the ones that I watch occasionally, and it's and of course I watch what's his name, Mr. Carlson's Lab. Where's he? Lost it. Mr. Carlson's Lab. He's a guy. He's got a Mr. Carlson's lab, he's another Canadian. He slow time restores old radios. You can see there's a video there that's an hour and 8 minutes long. There's one for that's 2 hours long. A Yaesu FT1000 he fixed. So they last a long time, but I find that tremendously watchable. Excuse me. So there you go. Everybody happy?
Yeah.
Right. Have I fulfilled the brief, Simon?
I think so. I mean, the proof of the pudding's in the eating, isn't it? If people go forward, but yeah, I think what's the right way of saying it? I think demystifying it's helpful, right? Talking through the tools and the terminology, that's always really helpful for people. And again, just watching somebody do it, I think, as you said, is really important because it's the one thing I would say from my own experience is practice makes perfect. It's well worth just getting bored.
Practice makes just hope it's a bit better.
Yeah. I mean, my soldering's not great, but certainly the more you do, the better you get. And I think it's something you need to get a go of. And Robin, thank you for spending the time and showing people. And hopefully somebody will pick up a soldering iron in anger and use it.
Yeah, just be careful which end you pick it up with.
Yeah, well, I think we've made that. Yeah. Well, I don't know. You only really make that mistake about 3 times.
Yeah. Yeah.
The worst one is that in my uni soldering labs, the soldering irons don't really flare out quite enough at the front. It's very easy to just, whilst you're fiddling, just your finger goes over and you burn your finger.
Yeah, this one, I've got one of these fancy USB ones and it's got almost no finger guard. So my one, it's really easy to just get a little bit closer to the edge. It really could do with just coming out a little bit as a little stop. I mean, you sort of feel it's warm, but I've done that a couple of times and just tapped it torrid and just caught the end.
As Paul says, if you can smell chicken, it's you're too late.
Oh, the worst is, have you ever welded?
Yeah.
If you're in the welding bay one day and you smell bacon, it's your head. Because as the spatter goes up, the smell of burning scalp is a lot like bacon.
Excellent.
Robin, thank you very much. I think we can probably draw stumps on the recording and then we can all relax and say naughty words. But thank you very much, Robin. That's much appreciated.
Well, thank you. I'll find the stop recording button.